In this lesson, I'm going to do two special right angle triangles. The first one which I'm going to do is 30, 60, and 90 degree. And the second one which I'm going to do is 45, 45, and 90. So basically we are going to find out the relationship between the side lengths. So 30, 60, 90, to start with this one, let's start with an equilateral triangle. So equilateral triangle is when all the sides are equal, which means the angle is also equal. So that's 60, 60, and 60. Now we need to find out the relationship of 30, 60, and 90. So I'm going to do a construction here. I'm going to draw a perpendicular bisector. You can do that from any vertex. Let's label it A, B, and C. So this is called AD. So AD is a perpendicular bisector. So perpendicular means 90 degree and bisector means this AD is dividing BC into two equal halves. So let's say if your BC is 2A, which means all the sides are 2A and 2A since it's an equilateral triangle. And now AD is a perpendicular bisector, which means BD is A. So I'm going to draw half of this triangle. So if I draw half of this triangle, so we have A, D, and B, and here we have a 90-degree angle because we had AD as a perpendicular bisector, and now from this diagram you can see BD is A, and AB is 2A, and also this angle B is 60, and as you know, some of the angles in a triangle is 180, so this is 30. And now we need to find AD. So let's say AD is x. Now using Pythagoras theorem, we know 2a whole square is a square plus x square. This is 4a square is equal to a square plus x square. This gives me 3a square minus 3a square is equal to x square. So x is equal to square root of 3a square, which is square root of 3a is your x. So this x is square root of 3a. So I'm going to label this 30, 60, 90. This two dots is for ratio. So now if you pay attention, opposite to 30-degree angle we have a, opposite to 60-degree angle we have square root of 3a, opposite to 90-degree we have 2a. So this is the relationship we are going to keep in our mind, and using this relationship we can even solve complicated problems. So now the next one is 45, 45, 90. And to do that, we are going to draw a right angle triangle, which is an isosceles right angle triangle. So this is 90, and which means 45, 45 is, this is 45, and this is 45, which means this side is equal to this side. And let's say this is A and this is A, which means this side we can find using, let's label it again, A, B, C. So now AC, to find AC, we can use Pythagoras theorem again. So a square plus a square, so x square is 2a square, and x is, we are only taking a positive value of a square root since it's a side length, it cannot be negative. So x is square root of 2a. Now we are going to set up again using the ratios. So 45, 45, 90, and you can see from the triangle here. So 45, opposite to 45 we have a, opposite to 45a, and opposite to 90 we have square root of 2a. So always keep this relationship, always remember this relationship also. The simplified version of this can be 1 is to 1 is to square root of 2. But I think this one, a 2 square root of 2a is more useful. And here also you can simplify it to 1 square root of 3 to 2. But again, as I said, I think this one is more useful. Okay, that's it for this video. I hope it is clear.